Chapter 2, Lesson 3 of Advanced Algebra, looking at direct variations, and we want to talk about interpreting direct variations in this lesson. And what I mean by interpreting is using now or applying the direct variation idea to word problems and to just other problems that we need to solve. And the one thing I want to start this video out by explaining is this. If you're told in any way in the direction that you have a direct variation, then in order to figure out the constant, all you need is one y and one x to figure it out, because we know in a direct variation every y over every x remains constant. So when I'm looking at a word problem or any problem at all where I'm given the instructions that this is a direct variation, all I need to look for in the problem then is one ordered pair, one x and one y that go together. I can put the y over the x, I can determine the constant of variation, which then allows me to write the equation, the direct variation equation, y equals kx. So keep that very important thing in mind as we go through this lesson. Now, like we did, or much like we did with functions when we read a function of, that phrase told us something very specific or indicated, or we were able to use that phrase to determine what the independent and dependent variable was by identifying that phrase in a word problem. It's the same thing with the phrase varies directly. As soon as we see the phrase varies directly, we know that our general equation is going to be y equals kx. And as soon as I know that, the only job for the rest of the problem is to determine what k is. And the k is, like I just stated a little bit ago, is 1y over 1x. That's all we need. So that's all we need to look for in the problem. So we want to look for this phrase varies directly because it indicates the type of equation we'll be looking for. And it always happens the same way that it happens with a function of, that phrase a function of. What comes first is always going to be our dependent variable, and what comes after is always going to be our independent. So this is always going to be y varies directly with x. It's always going to be the same. So identifying that phrase in a word problem becomes, again, makes the problem that much easier because now we know what we're looking for and we know exactly where to find it. The word varies directly, if we want to interpret that from English into mathematical language, every time you see the word varies directly, you can translate that into this expression equals k. That's what it means. There's always going to be a k and varies directly. And then the dependent is equal to k, the dependent is equal to the k times the independent, whatever it is. We then again, like I said, we need to just simply look into the problem, look for a y value that represents the dependent, look for an x value that represents the independent, put y over x, and I can determine k, which then gives me the equation that I want. Now, a very important thing to be aware of, again, as we go throughout the year, is you must always identify the variables that you're using. In other words, if you introduce variables into the problem because they're not given to you, then you have to state what those variables are going to represent. And I'll use that in a couple of examples. So for instance, some of the problems you run into is the amount of fines, the amount of overdue fines varies directly with the number of days overdue. So as soon as I see this phrase right here, varies directly, I know that this right here is going to be my independent, my dependent, or my y values, and what comes after is going to be my independent. Now, I'm not given variables, so here's what I have to say. The amount of overdue fines. So we're talking about overdue fines. So my overdue fines I'm going to equal to y, and the days overdue are going to equal my x. So then I can write the equation y equals k, that's what varies directly means, x, where y represents the fines and k represents, or x, represents the days. So it's always going to be the same. It's just a matter of introducing the variables and then defining them. All right. So let's do another example. So this does get kind of easy, kind of repetitive if you know what to look for. Again, the number of miles traveled varies directly with the number of gallons used. So this is the phrase that sets everything apart for me. So miles is going to be my y. So I need a variable for that. So I'm going to use miles, and I'm going to let we'll let m be that in this one. And then it varies directly with the gallons used. So gallons of gas. So the gallons is going to be, let's make that Z. So my equation, I translate this as to equals K. Miles traveled, I'm using M for that. Gallons, I'm using Z. So here's my equation. M is equal to KZ. And again, you can use any letters that you'd like, but that's really what it comes down to, is recognizing that phrase in a problem. So let's go one step further and actually write the equation and a model, okay? And remember, an equation is simply a model. So it says here, a dripping faucet wastes a cup of water if it drips for 3 minutes. The amount of water varies directly with the amount of time used. Well, there's that phrase we're looking for, varies directly. So what comes before it? The water. So the amount of water that drips, okay, so water is going to be my dependent. I'm going to use W for that. Varies directly with the amount of time. So time, I'm going to let that be my X, and I'll just go ahead and use X. So what's my equation? Y, or W in my case, varies directly with X. So here's my equation. Now the model is going to be this equation with a value for K. So what I have to do now is find the value for K. And so what I have to do is go back into the problem, and I remember that K is going to be equal to Y over X, or in this case, W over X. So I need to go back into the problem and find a value for water wasted that I can put in here, and I need to find a value for time that I can put in for here that will give me my K. Well, it says right here, a dripping faucet wastes a cup of water. A cup, that's 1 cup. So 1 cup of water if it drips for, and here's 3 minutes. Well, there's my time, 3. Now in this case then, my K is 1/3. So my model is going to be W equals my K, which I now know is 1/3, X. There's my model based upon this problem. Now the last thing I didn't talk about that you should do here is that these variables that you use and these quantities that you use, you should identify the units as well. Because here it says a faucet wastes a cup of water. So when I put a value in for W in my equation, it has to be measured in cups. I can't use ounces of water because that's not what the 1 represents. Those weren't the units I used when I came up with the equation. And time here is measured in minutes. So we should always put what those are measured in, because again, if I wanted to know how much water was wasted in 4 hours, I can't put 4 into my equation because this value that I used to come up with the constant is measured in minutes, not hours. So always define your variables, always give units for your variables, and then again, it's simply writing the equation and then going back into the equation to find your values that allow you to come up with the constant. So that's how you interpret or use direct variations. You need a Y and an X to come up with a constant to write your model.